Mara G. Aspinall is a healthcare pioneer and industry leader. She is currently managing director and co-founder of Bluestone Venture Partners, a venture fund investing in life sciences technology companies based in the Southwest. She started her business career at the strategic consulting firm Bain & Company, and she holds an MBA from Harvard Business School as well as a BA from Tufts University. Mara is actively involved in numerous ventures. In addition to her duties at Bluestone, she is also CEO of the Health Catalysts Group. She serves on the boards of Abcam plc, Allscripts, Castle Biosciences, OraSure, and Blue Cross Blue Shield Arizona. Mara has also served as president of Genzyme Genetics and Genzyme Pharmaceuticals, which was sold to LabCorp for $1 billion. Mara recently received her certification in cybersecurity oversight from Carnegie Mellon University. And as president and CEO of Ventana Medical Systems, a division of Roche Tissue Diagnostics, Mara led her world-class team to global leadership in companion diagnostics. Mara specializes in educating policymakers on personalized medicine, and she served as an advisor in both the Obama and Bush administrations. Mara co-founded the School of Biomedical Diagnostics at Arizona State University, which awarded their first master's degrees in diagnostics in 2015, and presently has 120 students involved. A few of Mara's bona fides would have to include becoming Arizona's Bioscience Leader of the Year, one of the 100 most inspiring people in life sciences, and one of Women Inc.'s most influential corporate board directors. She's clearly not an underachiever. Let's extend a warm virtual Rotary welcome to Mara Aspinall.
Hello, I'm very happy to be with you today to talk about diagnostics for COVID-19. I believe they are the key to the beginning, middle, and end of the pandemic. First, I'm going to talk about the disease, COVID-19 and SARS-CoV-2. Then I'm going to share some numbers, and then I'm going to go into diagnostics and end with strategies for back to work. So when I start, let's discuss the virus versus the disease. The virus itself is called SARS-CoV-2, Severe Acute Respiratory Syndrome Coronavirus 2. This was called coronavirus because, as you can see here in black and white, the first person that looked at the virus under a microscope thought it resembled a crown, and corona is crown in Latin. So that's the virus that causes the disease, which is called COVID-19. When you think about the disease, it most aggressively impacts the lungs. And let's look here at the lung of a 77-year-old man, and you can see day 5, his lungs look normal. Day 15, you start to have more white in the lungs, which is infiltrate and fluids. By day 20, the lungs have been overwhelmed by other material. And by day 30, unfortunately, this gentleman passed away. That's the disease that is caused by SARS-CoV-2. But as a disease, how does it compare to other diseases we need to fight? And I'm going to focus now on the flu. Many people have said, well, is this just a bad flu? So let's look at the worst flu season we've had in the last 20 years, and that was 2017-2018. So as you can first see the number of cases, right now in the middle of the pandemic, in the US we're at 2 million cases. Flu, worst year, 45 million. Hospitalized, many, many more patients were hospitalized for the flu, at least to date. But it's critical to recognize that the average length of stay for COVID patients is as much as 20 days. For the flu, it's closer to 4 or 5 days. So the profile of hospitals is very different for the flu than it is for COVID-19. But where the real differentiation comes, unfortunately, is the death rate. To date, we've had 110,000+ people die in the US for COVID-19, and we're in the middle of June. I suspect I'm sure that it will continue. When you look at the death rate, it's just over 5.5% for COVID-19. And in the worst year, 2017-2018, less than 1%. If you take the most virulent flu seasons, it's 1% death rate. So unfortunately, COVID-19 has roughly a 5 times higher death rate. So let's look at the numbers and the devastating impact to date. Just under 2 million cases in the US and more than 110,000 dead. When you look at the hotspots, things have changed a lot since the early time of the pandemic, and what you see is a shift from the major cities to the secondary cities. In this chart, the lighter colors, the light blue and the light yellow, is a reduction of disease or the same, but the darker areas are increases in number of cases and number of deaths. And you'll see that shift from the primary cities on the coast to the secondary cities, especially in the Midwest and in the South. So where does testing come in? Well, first, let me give you an overview for the US testing, and then I'll drill down in individual states. For the US as a whole, since the beginning of the pandemic, roughly 9.5% of tests came back positive. How many tests are we doing? We're now at close to 500,000 a day, which is great news, but we need to do better. It's terrific that we've made so much progress, but more to come. So if we look at that, we know that the U.S. is not a monolith. It's not about the entire country, but looking on a state-by-state basis. And what you can see here is that the average is 65 tests per 1,000 residents, which is, I don't know if it's good or bad. I would say it's not good enough. But the biggest issue here is where does each state perform? And you could see a number of states, not all in the New England, but you have Rhode Island, New York, and also New Mexico are amongst the highest testing states. In Arizona, we've moved up from 47th and 48th to 42nd or 43rd in testing. But clearly there are a dozen or so states at the bottom here that are significantly below the national average. How does that compare to our states in the western part of the U.S.? Well, I've looked here at 4 states, Arizona, California, Nevada, and Oregon. And what you can see in all of the states is that we've had recent increases. Some would call it a second surge, particularly in Arizona, where the cases have been up more than 80% in the last few weeks alone. Really dramatically high. California, the most moderate increase in these. Not surprisingly, and typically 10 to 15 days after you see a spike in cases, you will see a spike in deaths. And you could see the death rates go up and down, but continue to be at least the same, if not rise, in many of the states. The good news here about the death rate is it is decreasing. We'll see that in hospitalizations in a few minutes, which looks like the disease itself is fading a bit. On average, disease is less severe for people getting it today than people who are getting it at the beginning of the pandemic. So now let's drill down on where we are in Arizona. As most of you know, we are in the process of having the second surge. Of our top 15 days of new cases, 13 of those days happened in the last 2 weeks. A significant increase, unfortunately, since reopening. More on that later. The deaths have been all over the case. The reporting for deaths is not as consistent as the reporting for cases, and I suspect we will have another spike in deaths 10 to 15 days after the spike in cases. So where are we? Well, I would say it's a long way from New Zealand, not just geographically. New Zealand was just yesterday declared COVID-free. The government in Arizona has been talking about the official view, and I certainly hope we return stronger. Indeed, there's a decline in percentage positive cases, but the decline in cases is not as aggressive as the increase in number of testing. This recent surge in cases is not just about testing. It's important to note that statewide, testing is up about 35%, cases up 85%. In Pima County, testing is up 14%, cases are up 34%. Testing had something to do with it, but does not explain the whole story. So what are the consequences? Well, I say we've got to recognize this spike, and we've got to test, trace, track, and treat. and we need to have constant vigilance with social distancing and masking. But from an individual point of view, if you have not already recovered for coronavirus, what's your question? How will I be taken care of? So there's some good news here, that the number of hospital admissions is declining. And that's consistent with what I said earlier. On average now, we're finding new cases are less severe than they previously were. Now only 12% of known cases are hospitalized. That's down from a high of 20, and then 16, and now we're at 12%. So that's the good news. But there are two pieces of information that I think are surprising to many people. Number one, 61% of the people who are hospitalized are low risk. They had no chronic condition, and they are under 65 years of age. The death rate is still much higher in the older population, but it is not true that those hospitalized are all of the older populations. It is across the entire spectrum of our ages. Secondly, of all the people in Arizona who have been hospitalized for this disease, 1/3 are still inpatient today. So that's concerning that there are still a lot of patients still in the hospital. But is there room for all of us? Just this morning, the hospitals redeclared their emergency processes, and I'm pleased to say there are 22% of beds available. As recently as last week, it was only 15% of beds. So if there is an additional surge, at least we have beds open. I think it's important to note that in Arizona, we've never had a shortage of beds. We've never had a shortage of ICU, and we've never had a shortage of ventilators. So from that perspective, you can feel confident that our healthcare system can be there to help you if needed. So now let's move to the diagnostics piece. Everyone wants diagnostics. It's every single headline. How many are there? Well, there are a whole lot of them. My firm has put together what I believe to be the largest database in the country, and we have counted 997 tests. About 60% of those tests are looking for the virus, active virus, 40% looking for the antibody, a variety of different technologies, and these tests come from all over the world. As truly a pandemic, the tests are pan-global. So how is the FDA dealing with this? Many of you may be familiar with the fact that the FDA approves all drugs, procedures, and diagnostics. Well, the FDA started by saying this is nothing different. We're just having regulation as usual. You've got to come to us. They had a lot of pressure to allow these tests to get to market. And after about 10 weeks of what I call denial, they opened up the floodgates, and they had unprecedented relaxation. You could launch a test before you registered it with the police, and not only could the federal government approve tests, but the states could approve tests. We then have 8 weeks of what I call regret, where we saw a lot of lousy tests on the market, and the FDA decided it needs to react. And just a few weeks ago, they entered the next stage, which I call cautious retrenchment. And in doing that, there are a number of crackdowns that the FDA has put in place to ensure the quality of these tests is better than it had been in the past. They also began taking tests off of the market, recently taking 27 tests off of the market. I think that is unmitigatingly good news. So with so many tests, what do I do? What's the difference between a virus test and an antibody test? Does it matter if they go in my nose or I spit, or the front of my nose or the back of my nose? And how do we use testing to reopen society and ultimately our economy? Well, I will say first that diagnostics are powerful in every stage of the disease. I call myself a diagnostic evangelist, and it is critical that we understand where diagnostics will be helpful. I'll only focus on 2 types of tests today, but I'll just outline these at a high level, starting with how vulnerable is this patient. I believe we will find out that some people's genetics make them more vulnerable to this disease than other people. We then look at symptomatic testing and asymptomatic testing, otherwise called active virus testing. We'll then look at antibody testing. And the last piece, which has not had a lot of discussion to date, is the virus gaining or losing virulence? Is it mutating? And many of you are familiar with AIDS or the common flu. It changes season to season. That's why you need a new flu vaccine every season, because the virus itself mutates and there are different strains that impact us. We don't know if this virus is changing enough to make that relevant, but the diagnostic and the information that comes from it is the only way to gauge that. So let's talk about the two most basic type of testing. One, on the left, and will always be on the left and in red, is do I have COVID-19? Then the second question that's asked is, do I have antibodies to SARS-CoV-2? And those are going to be in green. So let's look at the virus test first. The question is the virus present? At the beginning, the only way we could diagnose people was through a lung X-ray or a lung CT. We now have nasal tests, and I believe we'll ultimately have saliva tests to look for the virus's RNA or DNA or antigens. On the right, in green, are the antibody tests. Do I have antibodies for this disease? And it's not just afterwards, it's also during the fight against the disease to say, is the virus winning or are the antibodies winning? What's most important as a layperson here? What I call the so what test. What's most important on the virus? It's no false negatives. You never want to miss a case and be told you don't have the disease when you do. On the antibody side, it's about no false positives. You don't want to be called immune, more on that later. You don't want to be told you've already had the disease and recovered and not have that be true. So the way we design these tests have to be fundamentally different. Why is that important? Let's look at a clinical trial of patients. And you can see that on day one, 100% of the patients, not surprisingly, had virus. 50% had antibodies. Over this period of time that is typically crosses over at day 12, you can see that the virus starts to lose strength and the antibodies start to gain strength. This is a key factor. On average, it's 12 days, but it's important to note, and I'll share some personal information in a minute, that a third of patients at the end of 21 days still have virus. Is it enough virus to infect others? Quite frankly, we don't know yet. We believe it isn't as a scientific society, but that's why everyone talks about not going out in society after you've had the virus until you are 2 full weeks without any symptoms. From a personal point of view, I'll put it in here because this is very difficult for me. I've had 7 of my family members in New York who were declared positive. 1 indeed passed away. She did have other chronic conditions, and it was brought into her home. She was bedridden with her nurse. Very sad. I had 2 other of my family members who had COVID pneumonia. One struggled for 36 days. The other one struggled for 28 days. So this whole idea that it's only a 14-day course of disease, I can't emphasize enough, that isn't true of everyone. In my life outside of New York with my friends, I know 14 people who are positive. I try to keep up with them. Most of those have recovered, but some are still fighting today. So for this disease, it's very personal to me, and I'm sure for all of you, if you've known somebody or know somebody today that is fighting, you can really get the sense of the devastation and the unpredictability of this disease. It's not just a respiratory disease. We don't call it just respiratory anymore. It affects the neurological involvement, it affects the peripheral neuropathy with hands and feet, and it affects the amount of fatigue a person has. So I digress a little bit, but let me go back to the presentation and focus on these tests so we can all get tested at the right time. So what are the pros and cons? You have all these tests. How do they work? Well, on the red, the nucleic acid tests, sometimes called PCR tests. As I talked about, these are typically swabs. You've seen that on television. This is what a swab looks like. They're called non-invasive. They're very accurate. They can catch only 100 copies of the virus. The typical patient has 100,000 up to 300,000 copies of the virus. So 100 is plenty good enough to make a diagnosis. But the sampling is really tough to do, and technique is critical. You'll see that in a minute. On the antibody side, what you find here is it's all about blood. And the good news about blood is if you have antibodies in some of your blood, you've got antibodies in all of your blood. So it could be a finger stick, it could be a blood tube. But the challenge here is about test design to make sure the test is accurate. So let's talk about these pros and cons in more detail. Remember, I just started talking about these viral tests. What does this look like? You may need to shield your eyes, but this is what these nasal swabs look like. It's called tickling the brain. It is a long way in, and technique is really critical that it doesn't hurt you and it gets to the virus in the back of your nose. But is that the only way to do it? That is the standard way now, and that's because the oral swabs in the front of your mouth, to date, they only had a success rate of 32%. Those nasal swabs, 63%. Sputum, i.e. when you cough, does have a positive rate of 90%, but part of the challenge with this disease is it's most often what's called a dry cough. So it is very hard for patients, especially at the beginning of disease, to cough up something to test. The question then becomes, what about saliva? Why aren't we testing saliva? We test it for genetic diseases, we test it for your DNA. Well, this has changed. If we look at saliva as a testing mechanism, you can see that it's in dispute. The older study said saliva does not work. There is not enough virus in saliva. Well, that's changed. As the tests have improved, we now see that recent studies are saying, yes, saliva captures more virus than NPS, where these NPS are the nasal swabs. So it's interesting. Stay tuned. I believe you will see many more saliva-based tests, not just in a doctor's office in a hospital, but these tests going home. So when we talk about home testing, that's probably the question that I'm asked most. Can I do it at home? Do I have to go to the doctor's office? Do I have to go out? Well, the answer is not. You don't have the full ability to do it at home yet, but I believe it'll change. Number one, sample collection at home is just beginning. Remember, red, active virus testing, green, antibody testing. These nasal and throat swabs, you can do at home. You can collect at home and then send in the mail. Sputum and saliva, you can also collect at home, but remember, it has to be first thing in the morning. You have to cough up something and then spit it in. Accuracy has not been as high as we would like, but I think it's getting better. Lastly, antibody tests. And the antibody green tests are always in the blood, and these are finger stick tests. And what happens with these, similar to a test for glucose for diabetes, is you prick your finger, and a little bit of it goes into this kind of pack of gum size cartridge, and then you send it off. But what's the holy grail here? What do we want to see? What we want to see is a full DIY test. And I believe in the next few months, we will see that. I show as an example here a 20-minute HIV antibody test, which can be done at home. I believe we will see this. Many, many companies are working on it, but none have been approved yet. So those were the challenges with the virus test. Now let's talk to the antibody tests. What are the challenges here? Well, first, on the top line, you'll see this is the genome sequence for SARS-CoV-2, the virus that causes COVID-19. And what you'll also see is this blue line. And what is that blue line? That's bat coronavirus. And why is that relevant? It has a 96% overlap in its genetic composition. And as a result, that's why we believe this started in bats. But more relevant, let's look at other coronaviruses. There are at least 5 other coronaviruses that overlap in a very big way with this coronavirus. And that includes the common cold. So it's very important when we create an antibody test for SARS-CoV-2 that you find out whether you have antibodies to this coronavirus, not to the others. And you can see from this cartoon that there are some areas where if you sample right here at this position in the genome, you might find have antibodies, but it's to the wrong coronavirus. So it's critical that this works well. The other challenge with antibody testing is false positives. So I'll try to explain this in a very good test, one that's 100% sensitive and 97% specific, which means there are 3% false positives. So it doesn't sound like a very big number, 3% false positives. But what's key here, back to college statistics, is that you can only have a false positive against those that might be positive. So if you look, and that might be negative, if you look at New York City, they have 21% of their population is truly positive. So this 3% is only against, in this example, 248 people, only 10%. But if you look at Tucson, Arizona, and the recent data that came out of University of Arizona's first 6,000 tests, as you can see that here, it is 1.5%. It was rounded, I rounded it up from 1.26 to 1.5. And what you can see here is that 3% is on a much larger sample. And it could be as much as 66% with a false positive. So what I'm recommending is that anyone who tests positive for an antibody test, if you are someone who didn't have symptoms and you have no reason to believe you actually had the disease, I would have a second test to confirm that positive. So in conclusion, I want to talk about where we go from here. First, where do we go as a society? Well, I have 5 key issues for me. Number 1, testing must increase from its current levels, and I believe it's only going to happen in partnership with private industry. Number 2, we need to better treat patients. We would all be a lot less frightened, I know I would be, if we knew the death rate had gone way down and that if anyone gets sick, we know how to treat them. We are not there yet. Number 3, trace all the contacts of the infected. I know there's a balance here around privacy, but I think it's critical that we know if we've been exposed so you don't expose others. Next, speaking of exposing others, I believe we need to move to vertical quarantining. And I say vertical instead of horizontal. Right now, when we all shelter in place, that's horizontal quarantining. Vertical quarantining is about quarantining the vulnerable, cancer patients, nursing home patients, immunocompromised patients. That's who we need to quarantine. And those who are infectious need to be quarantined for a short period of time. And lastly, prepare for the next surge. There's no question in my mind we will have a next surge and we will have a new next epidemic. So where do we go from here? If you run a business, you're employed in a business, you lead a business, I'm going to go through 2 basic areas. One are the basics. I believe in employing a universal masking policy, not when sitting at your desk by yourself, but any time you are talking or interacting with others. I'm sorry to say, somebody who talks a lot, talking is the single most dangerous activity going forward. Secondly, reconfigure your inside office space. If your office is outside, you're in pretty good shape, but most of us, that's not the case. Make sure you're limiting meetings or gatherings to 10 people or less. If something happens, you are protecting your business by ensuring it only affects a small number. Lastly, create a strong and healthy workplace. Acknowledge that fear and success, over-communicate, train and educate your employees to talk and to give you feedback. But let's get to the details. I think there are 3 key things here as well. Number 1, segment your workplace. What I mean by that is who's at biggest risk to themselves and who's at biggest risk to others. Look at the public interaction. Look at your internal interaction. Look at where you're situated. Are you in a low market prevalence like Tucson, or are you in a higher market prevalence like Houston today? And look at your vendors and contractors. I recently read a very sad case about a company who had done everything right, but didn't speak to their vendors. And they had people coming in and infected 20% of the office. So think about all those scenarios. Secondly, implement testing strategy. I believe in active and frequent testing for active disease. Now, for everyone, For many companies, that's not necessary. But if you interact with the public or you have a group of your employees like HR who's constantly interacting with other employees, I think frequent active disease testing makes sense. If you're doing it on a very large scale, you might want to wait until the viral antigen tests come out more broadly. I believe they're better than temperature. They're worse than PCR, but they can be done in 15 to 20 minutes. And lastly, consider alternative work schedules. I like the one that a quarter of your staff comes in for 4 days. Then they go home for 10 days. What that means is if they got sick during that 4 days, they're likely to show symptoms when they're home in the next 10, and thereby stay at home before they're better. I think that this will help to minimize the spread, but start getting people back in the office. I also like the idea of requiring daily employee self-implemented health checklists. We know checklists make a difference. So each morning to have somebody look at their phone and see a very simple list of 5 things. Do I feel ill? Do I have a fever? Am I coughing? Do I have a loss of taste and smell? Whatever the CDC recommends is those things. And it's surprising. You say, well, I go through that in their mind, but the consciousness of having the checklist helps. And in conclusion, what's going to happen in the future? People are asking me this all the time. So I'm going to tell you what I see as the future. Let's call it the next 6 to 12 months. Number 1, additional surges are inevitable. Will it happen in every state? No, but it will happen in many states. I don't believe this blanket horizontal shelter in place will be required, but I do think these reopening events and rallies and protests will fuel the surges. Secondly, testing and contact tracing, I believe, is needed. I'm not sure it'll be widely used, or at least consistently used, and I believe that each of the large companies will have to implement it on their own. Third, vaccines. I'd love to believe that a vaccine will definitely come, but I have to tell you, there has been no vaccine for any other coronavirus. We've been trying to have a vaccine for the common cold for 40 years, and we haven't been able to do it. I hope I'm wrong here, but what I will say is I believe it will not be a one-and-done vaccine, and it will have minimum impact, even if it comes out in 2020. So I think this is 21 and later, if indeed the scientific challenges can be met. Next, let me talk about testing. I believe test quality will improve with these new validation protocols by the FDA. I couldn't be more happy about that. Secondly, on testing, home sampling, particularly finger to stick and saliva, will be broadly used. And I believe within the next, I'll call it 2 to 3 months, we will have a full test at home that we can implement ourselves. And lastly, though, multiple virus disease testing will be needed in the fall and in the winter. What that means is that somebody will feel sick, and we're going to want to know if I have the flu, do I have RSV, or do I have COVID-19? Because many of the early symptoms are overlapping, and it is critical to understand to better treat and isolate which one you have, if nothing else, than to manage one's anxiety. We all know how to deal with the flu. It stinks, and it is tough, particularly on the elderly, but it's a very different protocol than dealing with COVID-19. So with that and this somewhat sobering talk, I say thank you for your attention. I'm happy offline to answer any questions or to help in any way with the Rotary Group. It's a privilege to have the chance to talk to you, and please take good care and stay well. Thank you.